Chapter 2. The Geology of Ethiopia and the Horn. 2.1. Introduction. Geology is an earth science that studies the evolution of the earth, the materials of which it is made of, and the processes acting upon them. Much of geology is concerned with events that took place in the remote past when no one was around to witness them, and with features which are far beneath the Earth's surface where no one can see them. A great deal of geological understanding must, therefore, be obtained by inference, using clues from what can be seen and what can be measured. Not only the rocks and landforms which can be observed and studied at the Earth's surface, but also those provided by indirect methods such as geophysics, e.g. studying earthquake waves which can penetrate deep beneath the Earth's surface, geochemistry, analysis of the detailed composition of rocks which can give clues as to their origin, and geochronology, methods for finding the ages of rocks, usually from the radioactive elements they contain. Therefore, this chapter will focus on the geology of Ethiopia and the Horn. In this chapter, you will study the geologic forces acting up on Earth and their resulting landform, geological time scale and age dating techniques. Objectives. After completing this chapter, the students will be able to analyze the geologic processes and the resultant landforms of Ethiopia and the Horn. Examine the formation of the Rift Valley. Recognize the current status of Ethiopian mineral endowment associated with geologic processes. The Earth's continents were once bunched up together into a single huge continent called Pangaea. The large supercontinent was then split into Gondwanaland, where Africa is a part, and Laurasia, and later into smaller fragments over the last million years. These then drifted apart to form the present arrangement of continents. Australian climatologist Alfred Wegener proposed the hypothesis that the continents were once assembled together as a supercontinent, called the continental drift theory. Wegener's principal observations were: fit of the continents. The opposing coastlines of continents often fit together. Match of mountain belts, rock types. If the continents are reassembled as Pangaea, mountains in West Africa, North America, Greenland, and Western Europe match up. Distribution of fossils. The distribution of plants and animal fossils on separate continents forms definite linked patterns if the continents are reassembled. Paleoclimates. Rocks formed 200 million years ago in India, Australia, South America, and southern Africa all exhibited evidence of continental glaciations. 2.2. The geologic processes. Endogenic and exogenic forces. Geology studies of how Earth's materials, structures, processes and organisms have changed over time. These processes are divided into two major groups: internal and external processes. The internal processes, endogenic, include volcanic activity and all the tectonic processes: folding, faulting, orogenesis, mountain building, and eperogenesis, slow rising and sinking of the landmass. These processes result in building of structural and volcanic features like plateaus, rift valleys, block mountains, volcanic mountains, etc. The external, exogenic, processes are geomorphic processes. They include weathering, mass transfer, erosion and deposition. They act upon the volcanic and structural landforms by modifying, roughening and lowering them down. The landmass of Ethiopia, as elsewhere, is the result of the combined effect of endogenic and exogenic processes. Brief geological history of Ethiopia and the Horn will be dealt chronologically starting from the oldest era of the Earth's history to the recent. 2.3. The geological time scale and age dating techniques. The geological history is divided into eras. Each era is divided into periods. The eras are given names that indicate the kind of life that existed in them. For instance, the Paleozoic era, ancient life, is the age of invertebrates. The Mesozoic era, the middle life, is the age of reptiles, while the Cenozoic era, recent life, is the age of mammals. These geological divisions basically differ from each other in such characteristics as the relative position of land and sea, the kind of climate, and most important, the kind of animal and plant life that developed and existed during that era or period. Geological time is difficult to measure precisely. The Earth is believed to have been formed approximately 4.6 billion years ago, and the earliest forms of life were thought to have originated approximately 3.5 billion years ago. The first major boundary is defined by what was believed at the time to be the first appearance of life on Earth. The span of time before life appeared was termed the Precambrian era. To describe the geology and history of life on Earth, scientists have developed the geological time scale. The geological time scale measures time on a scale involving four main units. 1. An epoch is the smallest unit of time on the scale and encompasses a period of millions of years. 2. Chronologically, epochs are clumped together into larger units called periods. 3. Periods are combined to make subdivisions called eras. 4. An eon is the largest period of geological time. The division of time units in the geological time scale is usually based on the occurrence of significant geological events, e.g. mass extinctions. As such, the geological time categories do not usually consist of a uniform length of time. The geological time scale, illustrated in Table 2.1, is built largely on the basis of life and evolution. Table 2.1. The geological time scale. Our period began, in million years, and major events, million years ago. CENOZOIC. Quaternary 1.6 present major glaciers in North America. And Europe 1.5 tertiary 71.6 Rocky Mountains, 65 individual continents take shape. Mesozoic. Cretaceous 146 70 dinosaurs extinct, 65 Western Interior seaway and marine reptiles. 144 to 65. Jurassic 208,146 Pangaea, one land mass begins to break up. 200 Triassic 225,208 First mammals and dinosaurs. Paleozoic. Permian 290,225 Greatest extinction on Earth, 245 Pennsylvania. An 322,290 First reptiles. Mississippi N. 362,322 coal-forming forests. Devonian 408,362 First land animals and first forests. 408 Silurian 439,408 Life invades land. Ordovician 510,439 First fish appeared. Cambria 600,510 Great diversity of marine invertebrates. Precam. Brecan. Proterozoic 2500–600 marine fossil invertebrates, 600 Archean 4500–2500 earliest fossils recorded, 3500 earliest rock formation, 4000. Age dating techniques. There are two techniques of knowing the age of rocks: relative and absolute age dating. Of relative dating. Relative dating uses geological evidence to assign comparative ages of fossils. Hence, we can use two ways to know the relative age of a rock. One way is to look at any fossils the rock may contain. If any of the fossils are unique to one of the geologic time periods, then the rock was formed during that particular time period. Second way is to use the what is on top of the older rocks. When you find layers of rocks in a cliff or hillside, younger rocks are on top of older rocks. But these two methods only give the relative age of rocks, which one is younger and which is older. B. Absolute dating. Also known as radiometric techniques. This technique was developed with discovery of radioactivity in 1896. The regular rates of decay for unstable, radioactive elements were found to constitute virtual clocks within the Earth's rocks. Radioactive elements such as uranium U and thorium Th decay naturally to form different elements or isotopes of the same element. Every radioactive element has its own half-life. At the end of the period constituting one half-life, half of the original quantity of radioactive element has decayed. After another half-life, half of what was left is halved again, leaving one-fourth of the original, and so on. Two of the major techniques include a carbon-14 technique. Upon the organism's death, carbon-14 begins to disintegrate at a known rate, and no further replacement of carbon from atmospheric carbon dioxide can take place. Carbon-14 has half-life of 5,730 years. B. Potassium-argon technique. The decay is widely used for dating rocks. Geologists are able to date entire rock samples in this way, because potassium-40 is abundant in micas, feldspars, and hornblendes. Leakage of argon is a problem if the rock has been exposed to temperatures above 125 degrees Celsius, 257 degrees Fahrenheit, because the age of the rock will then reflect the last episode of heating rather than the time of original rock formation. 2.4. Geological processes and the resulting landforms of Ethiopia and the Horn activity. 2.1. 1. Distinguish between endogenic and exogenic processes. 2. What are the major geological processes and the resulting landforms of Ethiopia and the Horn in each era? 2.4.1. The Precambrian era geologic processes, 4.5 billion 600 million years ago. The Precambrian era covers 5/6 of the Earth's history. Due to its remoteness in time and the absence of well-preserved fossils, our knowledge of the events is limited. Nevertheless, some general description of the main geologic processes can be made. The major geologic event of the Precambrian era was orogenesis. As a result, the land was subjected to intense folding. This was accompanied by intrusive igneous activity. The result was the formation of huge mountain ranges. In between the orogenic periods and after the last orogenesis, there were long periods of denudation, which finally reduced these mountains to near-level penaplaned rock surfaces. This leveled surface was later, in the Mesozoic and Cenozoic eras, covered by younger rock formations. Therefore, in most parts of Ethiopia, rocks belonging to this era are found beneath all other rocks, forming the basement rocks. Since they have been subjected to pressure and heat from overlying weight, earth movements, folding, orogenesis, and to intrusive igneous activity, the original rocks, both sedimentary and igneous, were altered into metamorphic rocks of varying stages of metamorphism. Since these same processes have allowed mineralization and crystal formation, the rocks are also collectively described as crystalline rocks. The Precambrian rocks are overlaid by recent rock formations. However, as surface rocks covering 25% of the land mass of the country, they are found exposed in the following areas. In the northern part, western lowlands, parts of northern and central Tigray. In the western part, Gambela, Benishangul Gumuz, Metekel and Asasa, western. Boijum, western Welega, Ilyababara, and Abay Gorge. B. In the southern part, Guji, southern Omo, and parts of southern Balan. Barana. C. In the eastern part, eastern Hararg. 2.4.2. The Paleozoic era geologic processes, 600,225 million years ago. The Paleozoic era lasted for about 375 million years. The major geological process of this era was denudation. The gigantic mountains that were formed by the Precambrian orogeny were subjected to intense and prolonged denudation. At the end, the once gigantic mountain ranges were reduced to a penoplaned surface. Undulating plain with some residual features, Inselbergs, here and there was formed. The sediments were transported southward and eastward to form continental, in Africa, and marine deposits, respectively. The limited deposition within Ethiopia, rocks belonging to this era are rare in the country. 2.4.3. The Mesozoic era geologic processes, 225 to 70 million years ago. This Mesozoic era lasted for about 155 million years. It's an era of alternate slow sinking and rising, eperogenesis, of the landmass. This process affected the whole present-day Horn of Africa and Arabian landmass. At the same time, the land was tilted eastward and therefore lower in the southeast and higher in the northwest. The subsidence of the land began about 225 million years ago. As the land sank slowly, the sea invaded it, starting from Somalia and Ogaden and slowly spreading northwestward. This was in late Triassic. This phenomenon continued up to Jurassic period. As the shallow sea spread towards the land, sands were deposited over the penoplaned Precambrian rock surface. As the depth of the sea increased, mud, shale, gypsum and later lime were deposited. Associated with the flourishing of marine life and decaying and precipitating of their remains, as the sea stayed long. Hence, Mesozoic rocks are considered to have the greatest potential for oil and gas deposits. Through time, compression by the overlying rocks and by cementing minerals, the sands and lime were compacted to form sandstone and limestone layers respectively. These are known as the Adigrat sandstone and Hintalo limestone layers. They are named after place names in Tigray where they might have been first identified. In the Horn of Africa and Ethiopia, the slow rise of the land and consequently the regression of the sea began in the Upper Jurassic. It continued throughout the Cretaceous period. With the retreat of the sea, another process of deposition occurred. In the country, sedimentation ended with the deposition of clay, silt, sand conglomerate brought in from the land as the sea receded due to uplift of the landmass. Gypsum, shale and at last sands were laid over the Hintalo limestone. The uppermost layer is known as the Upper Sandstone. By the end of the Mesozoic era, when the land emerged out of the sea, three major sedimentary formations were laid and formed upon the Precambrian rock surface. These were the Adigrat or Lower Sandstone, Hintalo limestone and Upper Sandstone. As transitional formations, gypsum and shale were interbedded above and below the Hintalo limestone. The Mesozoic sedimentary rocks cover 25% of the land mass of the country. Due to the tilting of the landmass during the transgression and regression of the sea, and due to the direction of the invading and retreating sea, the age and thickness of the sandstone layers vary in a southeast-northwest direction. The Adigrat sandstone is older and thicker in the southeast and progressively decreases in age and thickness northwestward. The Upper Sandstone, on the other hand, is thicker and younger, Upper Cretaceous, in the southeast, while in the northwest it is older and thinner. Transgressing sea and Mesozoic sediments nearly covered the whole of Ethiopia. The northwestern limit was as far as central Tigray, and western slopes of western highlands. In most parts of Ethiopia, the Mesozoic rocks are overlaid by the Cenozoic rocks. As surface rocks, these old marine sediments are extensively found in the southeast lowlands. Other exposures include central Tigray, and along the gorges of Abay and Wabashabel rivers. Figure 2.2.